Hello and welcome to T3 Alliance and your weekly show. I'm Adam and we're here in Hilo and it's a little bit rainy out today, but today we're gonna take you into a little bit of utilizing Scratch and how to do basic programming. We're getting started on lesson number 5. Now I'm just jumping back over here to my screen from where we were last week. We had zoomed in and dealt with building the Raspberry Pi kit and computers, Raspberry Pi, and the Internet of Things. I realized that, gosh, I didn't make that link live, so I'll update that in just a little bit. It's got our show from last week where we talk about what are some different ways that we can use Raspberry Pis in our community. But today we're going to delve into both Scratch and basic programming and Node-RED and programming the GPIO pins, because so you know a little of my background. I was a makery teacher, a makerspace teacher, and I had 20 students in middle school who are using Raspberry Pis, and for me, Scratch was a really powerful tool, and we'll jump into it a little bit. We'll give you guys a little bit of an introduction. I'll show you what to do, but as I've been speaking with teachers out there who are going through this curriculum, some people find that Scratch is, well, it's something that kids have been doing for a while. So if that's your scenario, then Scratch is one of those things you can skip and move through. But we can learn some big idea things about that. And then today I do have my computer set up over here, and we are ready to actually plug this thing in. If your students are where I think they are, they're excited, they're ready to go, and ready to jump into what can I do with this thing. I've got it, I've built it, I plugged it all in. They spent a few days, or they spent just a minute if they plugged it in, like noticing that it looks a lot like a regular computer. But now's where we go back to that idea that it's not just a regular computer, it's a computer with, there we go, it's a computer with some power behind it. So I'll share this presentation with you and come back to a kind of a refresher here. There's basic inputs and outputs on the Pi. Remember last week we already talked about what makes a computer, but when we think about what do you do with a computer, the big power that comes from a computer is the ability to give it its sets of instructions so that it can do things that once took a lot of paper and pencil or logic and there's a number of computer programs that come built into your Raspberry Pi, things like Scratch, C++, JavaScript, Node-RED, and these are all different ways of giving a computer a set of instructions. I like to break it into two different categories. One is visual programming languages, and the other is text-based programming languages. And for a student, they can know that both of them get the job done. One of them has a little bit of something at the end of it which helps it understand the difference, but they both have the same purpose of explaining what's this step, the next step. But concepts are pretty universal, whether or not you're using it in a text-based programming language or if you're using it in a visual-based programming language. And there are things like variables, things like loops, conditional statements, and if-then statement. These are things that computers are very good at doing. So we, in this program, use visual programming first, and then later on we can recognize that students can jump into using text-based programming languages, things like Python, Java, and other things. I will recognize that when we got started with T3 Alliance, we saw Minecraft and said, oh my gosh, Minecraft and Python, you can do both of them at the same time, and it is possible to teach a student how to use Python by playing with Minecraft, but there are possibilities for errors that can come up that allow a student to not feel successful. So our big one that we focus on here is there's a special computer program called Node-RED that we'll spend the majority of our time on, and it's all about Internet of Things. It's been built by some people who said, let's make this as easy as possible so that we can start building stuff utilizing the power of the Pi, the power of some of the pins that come off of it, and we can spend time playing. But when as a former teacher, I have to recognize that Scratch is awesome, and I'm putting this one in here so that in the event that you know your students and you know that they're coming in as brand new beginners, then you could spend some time letting them play with Scratch on their computer. You could say, I want you to make a Scratch program, and I want you to have a sprite that does things. What you can see here, this is what a basic Scratch stage looks like, and you can open up Scratch by clicking on Programs on your computer and go into Scratch, and you'll see that there's a little sprite, otherwise known as, the thing that you're controlling. This sprite has like a set of motion commands that are instructions for how it moves across this stage here. And if you look here and click on motion, you'll see that there's a bunch of commands, 10 steps, 10 pixel spaces, 10 moves that can be put in sequence. And a sequence of steps is essentially the simplest kind of computer program. So as just a beginning place, coming in here, you can watch as you put a set of instructions in and have a cat do something. So playing around with it at first is like stage 1. Oh, let's watch our cat move. Okay, and then stage 2 might be, all right, let's make this cat dance. And one of the things I like about Scratch is that in the event that you're a busy teacher with a lot of students who are raising their hand asking for help, this one has built-in tutorials. Scratch exists both online, so that you could open up a computer and go to any browser and just type in Scratch, and a student could either log in or just play along as a beginning user, and they could say, hey, let's do the getting started from Scratch tutorial, or let's animate your name, or let's make something fly. Any one of these things will give you a step-by-step tutorial that is very clear and kind of teach you each of the components that go along with it. But when you work with a group of students, the basics are understand your work area, that this is the area that you're working in, that there's a palette over here, and that you write scripts that go out here. These scripts are instructions to the thing there, or to the sprite. There's some concepts that come along, and these concepts are concepts that will translate over into other areas, into other programming languages. So the first concept of sequence. A sequence is a program. When you create a program, you need to think systematically about the order of steps. First do this, then do this, then do this, and then whatever. A loop or an iteration is if you said, hey, do this forever. A computer is very good at doing something over and over again until something, a repeating set of instructions. So kids very quickly find that if they put a sound in there and repeat it over and over again, it's kind of fun. Conditional statements, an if else or if then statement. If this is here, then do this. There are tutorials in here where you can learn to make games, make little activities. And what I come back to is that if you just set aside a time and say, everybody, you need to play, you'll be able to know that your kids who have some experience with this or your kids who don't have experience with this can both be growing. My brother's a computer guy, and he works on website stuff all day. He has a lot of knowledge on this, but when he jumped in and said, okay, I'm going to play for half an hour, there were some really cool stuff, and he was having a lot of fun as he messed around with this. So the ideas of variables, the ideas of lists. And what I like is that with Scratch, there are always opportunities to find that it only works when something is clicked from one place to another place. Each one of these little indentations, they represent something that will either work or it won't work. And if it doesn't have the right indentation, then it won't work. And in a similar fashion, when we translate over to stuff with text-based programming, if you miss a space, if you miss like an enter or you misspell a word, it won't work in the same fashion. But it's easier for people to see when it's a visual programming language. Threads are a kind of cool idea that, hey, a thread means that two things can be running on the same program at the same time. So these are some things that you can emphasize. I wouldn't spend too much time emphasizing it because kids want to learn and want to do something. They don't really care as much what is the fancy term that goes with this. This is more something that adults love. They love to know that, oh, I'm doing a random number generator. Well, a kid just wants to know what's happening here, and is my game working? So when I go through this with students, I usually spend some time playing, and then I end with a project that comes off of the Raspberry Pi Foundation. And it's the raspberrypi.org program called Astronaut Reaction Times. And I'll have that link in there for you. I think I have it right here. And this is an opportunity to share with you what is raspberrypi.org's website. The Raspberry Pi Foundation has a ton of resources that are helpful. And a computer with Scratch 1.4, it could be done on a Pi or it could be done on a computer, but it just comes native on your Pi. And they'll set the scenario up. Oh my gosh, there's micrometeoroids that hurtle towards people out in space, and we have to figure out what the astronaut reaction time is. So as you go through here, you learn that there's a handful of things that we need to constrain, we need to build, we need to paint our own background, and in the end, you will make an astronaut where if they say go or you say go, it will time how long it takes for you to hit the space bar on your computer. Remember, a space bar is just an input, and find out that your reaction time is this far, and the ISS, the International Space Station, travels 6 kilometers in this many seconds. So again, this is a game. It can be looked at in such a way that people are excited about playing it. The kids can say, holy cow, this was awesome. Look, I just did it. I just wrote my own program. Celebrate that moment, and then say, okay, are you ready to get on to the next thing? Because all you've done is use a computer program that's built in here. We haven't really unpacked the power of the Pi yet, but I've had students learn to make games with each other where one student hits the space bar and the other student hits the enter key, and they race who's faster at hitting the start stop thing. It's a simple game, but it gets the idea across. So in that sense, that's all I'm going to say about Scratch. If you want to use it, go for it. The link is down there for that website. I love it. I love to talk about this strand over time, but for the most part, just know that it's there. Now I'm going to switch to our next video, and I'm going to pause this one, and I'm going to start again, just so it makes 2 distinct YouTube videos that I'll put into my next one. And the next one is all about, let's learn to use our GPIO pins, these little things that come on our Pi right here, these little guys right here. We're going to learn to talk about these things and use Node-RED for the first time. So that's it for Scratch. I'll be right back on, and we'll talk about Node-RED. So bye-bye.